Hi, welcome back. So we're in Chapter 1, Introduction, and that is to discuss the subject of statistical power. In the previous section, we have just explored the two issues that cause a threat to the conclusion validity of our research. And the first issue was considering the investigation of a relationship between the space of variables, and the second one considering the acceptance or rejection of the hypothesis according to two scenarios of reality and scenario of alpha or beta. Now, what we want to do, actually, we want to develop a strategy by exploring number of components that we can rely on in order to kind of avoid or minimize the risk of falling on the trap of getting error from either issues. The first thing, start up with the following. Now, as you know, having you developed your research and you basically define that number or space of variables, you need now to start to measure values on those variable. So that's why you tap into the population. And basically the population, as you know, it is the entire environment where the problem for investigation have occurred. Now, for now, I will assume that the population have certain numbers. Now, what are those numbers? This is actually the purpose of this book. But imagine we will call those numbers for now points. There are some points that exist within that population. And those points actually a kind of a summarized number help me to understand the behavior of this population. Now, basically, as I said, we need to tap into that population and start to measure those variables. Depends on their outcome and come up to the conclusion. But of course, measuring the entire population or working with the entire population is a tedious task. That's why what we have come to understand that we draw a sample. And basically the sample, it represents a segment of that population. And what we hope for from this sample, I can calculate number of points again, because this is just a replica of the population. But since those points are not the original points, they are just the sample points, I will just indicate them with a hat on top of that points to differentiate the original points from the points hats that are calculated from the sample. Now, this graphical presentation, it is the actual reality on the purpose of analysis yet to come, because analysis basically relies on those points. It leads you to say something about the population, and it helps you to extract or to deliver solutions or to reach out to some conclusion from those points. Now, what we want a sample that can really be a good representative of that population. So to this end, we rely on a very important factor, and that is called the size of that sample. The larger the sample, the more likely that you are getting a better image about the population. Now, this is considered to be the first component of statistical power. The second one actually concerning those points that we were talking about. I would say, for example, imagine I have come to calculate point 1 and point 2 and etc. until point M. These are the points that represent a summary of the behavior of that population. Now, we want to consider these points from 1 to M has been drawn from sample 1, which is this sample. Let's say for the second chance, you have got another opportunity to draw a new sample out of that population. So this is my sample 2. And once again, as we always do, we want to calculate those points, and they are hatted points. Now I would have again a second vector of points, right, all the way to PM. Again, this is the second vector of those points, but those points have been calculated from the second sample, and so on. So the idea is, how much confident can I be that the differentiation of these points, like imagine point 1, on each sample I am drawing, to be actually very much close to each other? Because if I think that this point is a real representative of the real point from the population, means that my conclusion is quite a bit real things. So what I want to make sure that as many sample I am drawing in the future, always those points to be within a certain range. And that's why we develop something called the confidence interval. So basically the confidence interval, as the name is suggesting, that to develop that interval, set like a kind of a minimum to a maximum value. In this case, this interval give me the confidence that my conclusion, it's really a replica of what is going on with the real population. Now let's look at the third component of a statistical power. And in particular, this third component is to address the problem that we discuss of a relationship finding, that you assume there is a relationship when there wasn't in the reality, or you assume there is no when it was in reality. Now to address this issue, what we can do, we can calculate something which is called the effect size. And basically, as the name is suggesting, imagine that you have come to believe that x1, x2, and x3 have a relation to the problem. And you know they are contributing to the problem due to that kind of relation. So you're assuming the relation exists, for example. But at the same time, to address that margin of errors from reality perspective, what we can do, we calculate something called the effect size of each one of those variables. In other words, I would calculate how much percentage actually each variable individually is contributing to the entire problem. Now, the last component that we need to discuss is concerning the second issue, and that is the reality of two scenarios, of the alpha and the beta scenario. And basically that comes as follows. We set our judgment based on the null hypothesis for now. And the question, shall we actually accept or shall we reject this null hypothesis? Now, in order to choose either to accept or to reject, what we do, we come up with a value. We call it a p-value. It's a kind of a number, represent a margin or a level of confidence. Let's say, for example, this is the total level of confidence, 100%. Now, if you want to, for example, a 95% of confident, it means the p-value will be 5%. If you want to, for example, 90% level of confident, the p-value will be 10%. So if you want to, for example, 99 p-value of 1%, we need to compare this p-value against another number. So we need here a number that is in comparison with this p-value. And now the question is, what kind of number we're looking at? And that is the purpose of analysis. So analysis, it helps me calculate such a number. And basically, just from visual perspective, I want to tell you, this number is nothing but imagine the entire result or the entire points that we were talking about here from the samples are collapsed into this single number. So you might end up with a number could be larger or could be smaller. If the value of this number happens to be larger than the p-value, in this case, I would accept the null hypothesis. I'm going to repeat this for now because this is what we're going to learn about in much more details, of course, and intuitively better than that. But I'm just giving you the general idea. Once again, if this value or this number happens to be larger than the p-value, in this case, I'm going to accept the null hypothesis. And if this number happens to be less than the p-value, and I'm going to reject the null hypothesis. Now, this component is known as the statistical significance. So to recap one more time, the first statistical significance we have explored considering the size of the sample, and the second one considering the confidence interval. Then we have come to understand the effect size, which is addressing the first issue of threat to our conclusion validity, and the last one is considering the statistical significance. Now, I hope this a quick revision on the idea of threats to the conclusion validity and what is the meaning of some of the statistical power that we have just discussed are quite clear to you before you actually jump into the actual details of analysis and the steps and the tools that we use for such purpose. Now, before we start actually exploring the guide map on the idea of analysis, we will have a quick review on just some kind of guidelines also to improve your conclusion validity. I will see you then.